Welcome to homework.
We're given a bracket that has three different forces acting on it, and we're told what two of those forces are and their angles. We have to find the third force, and we're also told the magnitude and direction of the result force, which is directed along this positive x prime axis. And that axis has a magnitude of 800 newtons, and it forms a 60-degree angle with the y-axis, or a 30-degree angle with the x-axis, right? Force 2 has a force of 200 newtons, and it's directed straight upwards along the y-axis. And then finally, force 3 has a force of 180 newtons, and it forms a 5, 12, 13 triangle with the negative x-axis. So in order to find the magnitude and direction of our first force, which is unknown, we have to actually break down all of the horizontal and vertical components of all of our other forces and add them up so that they equal 800 newtons, the resultant vector. Right, so first, let's look at the horizontal components of these vectors. So if we write this out, our first force, force 1, equals, for the horizontal component, some value, I, and for the vertical component, it has some value, J. Right, our second force, F2, this has a value of 0I because it's just straight upward, so there's not even any horizontal component. And then since it's straight upward, it's 200 J. Finally, our third force, because it's a 5, 12, 13 triangle, which is a right triangle, we can use trig, we can use SOHCAHTOA to find the vertical and horizontal components of this force. So first, for the horizontal components, remember we need to find essentially this side, right? So we need to use cosine, which is adjacent over hypotenuse, right? Because we're looking for purely the horizontal component or the cosine of the angle. So here it'll be negative 180 because it's going in the opposite direction, negative 180 times, and because it's adjacent over hypotenuse, I'm going to take 12 over 13i. Then this is positive 180, and this, since it's vertical, we're looking for side, and in SOHCAHTOA that's so opposite over hypotenuse. In this case, that's 5 over 13. Okay, and our final component, FR, our resultant force vector, for the horizontal component here, we have 800 times cosine of 30 degrees, right? And this should be I, plus 800 times sine of 30 degrees. So we can actually break these all up into their own respective sections so that they add up to our resultant force vector. So let's take a look at x here, and I'll write this in blue just so it matches. So x minus 180 times 12 over 13 has equal 800 times cosine of 30 degrees. And as you can see, we just really took each of these components and added them up and set them equal to the resultant force vector component, which we already knew. So I'm going to type this into a calculator really quickly, and our value should come out to x is 858.97 newtons, or somewhere around there depending on where you round. We're going to repeat this really quick with our y, so I'm going to go ahead and underline all of our y components. So y plus 200 plus 180 times 5 over 13 is equal to our vertical component of our resultant vector, which is just 800 times sine of 30 degrees. And I'm going to go ahead and type this into a calculator as well. And this comes out to, double check, okay, yeah. So this y value comes out to 130.77. Okay, so now that we know both the x and y component, finding the magnitude should be fairly simple. We simply square both, add them, and then take the square root of that sum. So the magnitude of f1 equals, so let's square both of those numbers, square them, then add both those numbers. Finally, take the square root of those. And our final magnitude will be 868.9 newtons. And up here really quick, I'm going to use this space to find the angle. The way we do that is with arctan y over x, right? And so we can just plug this into the calculator as well. Lots of plugging in for this problem. And theta will come out to be, take this, 21.3 degrees. Okay. So, final answers are that our force is, our F1 is 868.9 newtons, and it forms a 21.3 degree angle from the positive or the x prime axis.